Hello everyone and welcome back. In this video we're going to look at a short way of finding the characteristic polynomial of a 2 by 2 matrix. Now let us consider a 2 by 2 matrix B, which is 4 2 3 4. Now let us find the characteristic polynomial of this matrix using the method that we know, and after that we're going to compare our answer with the shortcut I want to share in this video. Now, we remember that the characteristic polynomial of a matrix B will be given by the formula B minus lambda I equal 0. Find the determinant of this. Then, B is 4 2 3 4 minus lambda times the identity matrix 1 0 0 1 equal 0. Now, we have 4 2 3 4 minus, when you multiply lambda by this matrix, we have lambda times 1, lambda times 0, that's 0, then lambda times 0, 0, lambda times 1, that's lambda, okay, to give 0. Now, we have to subtract this matrix from this matrix, and that's going to be done element by element. So that will be 4 minus lambda, 2 minus 0, 3 minus 0, and 4 minus lambda, okay, equal 0. Now we need to find the determinant of this matrix. So if you want to find the determinant of a 2 by 2 matrix, so let's say matrix A, which is A, B, C, D. So if you want to find the determinant of this, it is represented by this. You put that A in 2 bar like this, and that is going to be this times this, okay, the first row, first column element times the second row, second column element, which is going to be A times D, then minus this times this as well, which is B times C. So that's how you find the determinant of a 2 by 2 matrix. So if you want to do that for this matrix now, it means that's going to be 4 minus lambda times another 4 minus lambda, then minus 3 times 2 equal 0, because this determinant is equal 0. So that is going to give us, so let me get rid of this because it's not part of our question. All right, so we are going to continue. I'm not able to get rid of that, so let's continue like that. So we're going to open this bracket. We have 16, 4 times 4, 16, then 4 times minus lambda, that's minus 4 lambda, minus lambda times 4, that's minus 4 lambda as well. Then minus lambda times minus lambda, that's plus lambda square. Then minus 3 times 2 is 6 equal 0. So we are going to rearrange. We have lambda square, then minus 4 lambda plus 16 minus 6 equals 0. So we have lambda square minus 8 lambda plus 16 minus 6 equals 0. So lambda square minus 8 lambda plus 10 equal 0. So this is the characteristic polynomial of this matrix B as given here up A. Now the formula I said, or the shortcut, is that if you want to find the characteristic polynomial of any 2 by 2 matrix, you can simply use this formula, lambda square minus trace of the matrix lambda, then plus the characteristics of that matrix, the determinant of that matrix. So for this case, the matrix is B, so we're going to put that B in 2 bars like that. So this is the characteristic polynomial of that matrix. Now what is the meaning of this trace? The trace is the sum of these diagonal elements starting from the first row, first column elements, then you add it with the other one in the diagonal. So that's going to be our trace. And in this case, as you can see, the trace is going to be 4 plus 4, which is going to be 8. Now this is actually the determinant of that matrix, which is going to be 4 times 4, 16, minus 3 times 2, which is 6. That is going to give us 10. So simply by substituting to this formula, we're going to have lambda square minus the trace, which is gotten to be 8 times lambda, then plus 10, which is the determinant. So this gives the characteristic polynomial of this matrix very easily. And if you check, it is the same as what we got here as well. Can you see? We have this, okay, So this is it. Now, actually, I made a simple mistake here. Okay, let me just correct that. If you want to find the characteristic polynomial, the formula to use is actually b minus lambda I not equal to, you not put anything like equal to 0. Now, there's something we call the characteristic equation. So characteristic equation is like the characteristic polynomial, but you're just going to add equal to 0. Okay, so that's just the only difference. So what we just calculated here, the first one, is actually the characteristic equation. But the only difference is just that we are putting equal to 0. So if you remove just equal to 0 in all of this, what you have left is called the characteristic polynomial, which was the intent of this video. But all the same, if you have to find the characteristic, equation as well, it still follows the same formula. So you can still use this formula and add equal to 0 to get your characteristic equation. So that's just the only difference between the characteristic polynomial and characteristic equation. So just characteristic polynomial, which is this, if you add equal to 0, you get characteristic equation. So that is it for this video. Thanks for watching. I do really appreciate it. And if you find this video very helpful, please make sure you subscribe to this channel and hit the notification button so that you can get notified whenever any video is released, and make sure you like the video as well. Thanks for watching.